reactions of carboxylic acids. That is the chemical properties of carboxylic acid. Okay, so the first one we'll talk about, which is the simplest one you should know, is neutralization reaction. Okay, neutralization reaction. Okay, so this is the reaction of this alkanoic acid with alkalis or bicarbonates to form salt and water and CO2, depending on if it's a carbonate, right? For example, if I have an alkanoic acid reacting with an alkali, let's say sodium hydroxide, what you're going to have in this reaction is a salt, okay, plus water. Okay, if it is an alkali, if it's a carbonate, let's say for example, this same alkanoic acid reacting with sodium bicarbonate, for example, this will still give you the salt plus water plus what? CO2. That's the reaction. Okay, simple. So any alkanoic acid you're using for the reaction will give you an alkanoate, a salt, sodium alkanoate or sodium alkanate, depending on the salt. For example, if I have, let's say, ethanoic acid, for example, undergoing a reaction with sodium hydroxide, this will give you CH3 COO plus water, right? So if it is a carbonate, let's say you have the same ethanoic acid or acetic acid plus sodium bicarbonate, this will still give you the sodium ethanoate plus water, then CO2 gas will be given off. Okay, that's this reaction. So number one. Number two reaction is esterification reaction. We have done this before when we are looking at alcohol. We have looked at this under alcohol. Reaction of this alkanoic acid or carboxylic acid with alcohols in the presence of a mineral acid to produce esters, right? So example is, if you react this carboxylic acid with alcohols, let's use prime to differentiate this. So the reaction is a reversible reaction catalyzed in the presence of a mineral acid. So that H2SO4. So this will give you an ester plus water. How did it happen? Remember, this will split OH. OH and H will give us water. Then RCOOR will give us the ester. So this is an ester. So we call this forward reaction esterification reaction. Example of such reaction is, let's use any specific ethanoic acid. Let's use ethanoic acid again, or acetic acid. It's called acetic acid. I hope you know. Ethanoic acid is also called acetic acid. Take note of this. So plus, let's use ethanol, or let's use methanol. Let's use methanol, for example. Okay. So in this reaction, the forward reaction catalyzed with an acid will give us CH3 COOCH3 plus H2O. What did I do here? Very simple. I took out the H from here, took out the OH from here. That will give us water. Then I joined this to this after removing the H. So if you join this H3, you have this. So this is called methyl ethanoate. This is called methyl ethanoate. Okay, and this is water, right? It's a simple reaction. So number three reaction is reaction with phosphorus pentachloride. So carboxylic acids will react with phosphorus pentachloride to form acid chlorides. Okay, so how do we do that? So carboxylic acid plus PCl5, this will give us RCOCl plus POCl3 plus HCl. So what happened there is simple. The chlorine replaced the OH, right? The leaving group OH, it leaves. So the chlorine replaced it from the phosphorus pentachloride. Then we now have one chlorine left, 4 chlorine left. So one of the chlorine picks up the hydrogen to give you this. So we now have POCl3. I have used 2 chlorines, now remaining 3. So that's how we got 1, 2, 3. This will give us a total of 5 chlorine. So if you check the equation, it's a balanced equation, right? Example, I can say let's use the same acetic acid again. Let's use this guy as a case study. Plus PCl5. So what happens is that the OH goes. Remember, what leaves here is OH. One chlorine comes here. So I have CH3, yeah, COCl plus the H goes to one chlorine to form HCl plus what is now left is now 3 chlorine, right? Plus 1 phosphorus plus the oxygen here will give you this compound, which is not needed. So the key answer to this reaction is this chloride. It's called ethanoyl. This compound you are seeing here is called ethanoyl chloride. Ethanoyl chloride. It belongs to the functional group called acid chlorides. So this is a simple reaction involving arachidonic acid and phosphorus pentachloride. So the next reaction we'll look at under carboxylic acid is number 4, which is going to be reduction. Reduction of carboxylic acids. Reduction. Now remember, reduction is simply the opposite of oxidation, right? So when we say reduction of carboxylic acid, we mean, remember that when you oxidize a primary alcohol, you get a carboxylic acid. So when you reduce the carboxylic acid, you get a primary alcohol. So reduction of carboxylic acid will give rise to what? A primary alcohol. So reduction of okay? Reduction of an arachidonic acid will give rise to what? A primary alcohol. Something like this. So what I'm simply going to do is to remove the oxygen and replace it with what? 2 hydrogen. So in this reaction now, for example, what do we use for this reduction? What we use for the reduction is we use lithium tetrahydroaluminate. So this is a reducing agent. Okay, this is a reducing agent. So in this reaction, let's say for example we have CH3 COOH undergoing reduction in the presence of this. Okay, so in this reduction process, this guy will lead to reducing this ethanoic acid to ethanol. So we have CH3 CH2OH. So what simply did is to remove this oxygen and replace with what? 2 hydrogen. That's what we just did. Remove the oxygen and replace with what? 2 hydrogen. So number 5 reaction is reaction with thionyl chloride followed by ammonia, okay, to produce an amide. So this reaction is quite simple. The reaction is simply converting the carboxylic acid to an amide functional group, amide, which is one of the derivatives, right? So how do we do that? If I have a carboxylic acid, for example, undergoing reaction with thionyl chloride, that is this guy, thionyl chloride. This thionyl chloride will reduce this guy to an acid chloride, okay, which is this. What happened here is that the OH will leave, the chlorine will replace it, right? So this one that is here will now further react with ammonia to give us an amide. That is, amide will replace this Cl. I now have RCONH2. Then one of the hydrogen from the ammonia, we pick up this chlorine, so we have plus HCl. So at the end of this reaction, we are going to get an amide. Okay, let's do an example. Let's use an example for this. Let's say we have CH3 COOH undergoing reaction with thionyl chloride. You're going to have ethanoyl chloride, right? You have this. Okay, so you subject this to ammonia. You have CH3 CONH2 plus HCl. Okay, so that is reduction followed by reaction with what? Thionyl chloride. So the next reaction, number 6. The next reactions of carboxylic acid to talk about is alpha halogenation. Alpha halogenation. Alpha halogenation of aliphatic carboxylic acids. So this halogenation is simply a kind of a substitution reaction that takes place at the alpha carbon of what? A carboxylic acid. First of all, where is the alpha carbon located? If I have a carboxylic acid COOH, the next carbon you see here is called an alpha carbon. The next carbon you see here is called a beta carbon. So this alpha carbon has what we call alpha hydrogen. So the any hydrogen you see here is called an alpha hydrogen. Any hydrogen you see here is called an alpha hydrogen. So when you carry out halogenation on this carboxylic acid, the alpha halogens are going to undergo substitution reaction to give you a halo carboxylic acid. Okay? So an example for this reaction is if I have CH3 COOH undergoing halogenation with chlorine. Okay? So what happens here is simple. The first chlorination stage will give you CH2Cl. Is that also COOH plus HCl. If I continue with this, let's say I do another chlorination reaction here. What will I have? I'll have CHCl2COOH plus what? HCl. If I also carry another one here, hydrogen will still react. Let's say another chlorination reaction here. I'll have Cl3, right? Then I have COOH plus what? HCl. Now, if you notice what happened in this reaction, what is happening is what? Is substitution reaction. The chlorine substitutes one hydrogen to give you a monochloroethanoic acid, sort of, okay? Then the next one will take place again. It will still go to the alpha carbon and replace the alpha hydrogen. Remember, there was two hydrogen here. So one will take place in this substitution reaction to form HCl, and then the chlorine replaces, right? Then the last hydrogen that is here, we also combine with chlorine to form HCl. The chlorine replaces, so we have this guy. So this is a trichloroethanoic acid, dichloroethanoic acid, and this one is monochloroethanoic acid. So this reaction takes place at the alpha position, alpha carbon, and what reacts is the alpha hydrogen in the substitution reaction. So remember that substitution reaction can also be carried out. You need for the reaction to proceed, there should be need for UV light or source of catalyst that can initiate this reaction.